Alright guys, we're going to move on to section 6.3 today, and I think you'll enjoy this section a little bit more than others because it's basically the section we just did backwards. So you're really not learning anything brand new, we're just learning how to kind of go backwards from what we already learned. Okay, so we're going to learn how to show that a quadrilateral is a parallelogram. Okay, so first thing I want to do is list the properties of the parallelogram. So take a minute, pause the video, and see if you can list them on your own. Alright, now that you have done that, here they are. See if you got them. Opposite sides are parallel, opposite sides are congruent. Opposite angles are congruent, diagonals bisect each other, and the same side interior angles are supplementary. Sorry, I spelled that wrong. There we go. Okay. So the first one, you're going to notice that you've seen these before, except they were backwards when you saw them before. Alright, so it says, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So again, if you're noticing that you see those opposite sides being congruent, we have 1 mark, 1 mark, 2 marks, 2 marks, then you're going to go and tell me, yes, this is a parallelogram. Same thing down here about the angles. If both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram as well. So again, you're seeing both pairs. 1 mark, 1 mark, 2 marks, 2 marks. Notice it does say both. Okay, you can't just have one pair being congruent. They both have to work out being congruent. Otherwise, it's not a parallelogram. Alright, so pause the video and see what you can do with these. Once you've had a chance to work on them, okay, here are your answers. So tell whether this is a quadrilateral, or excuse me, whether the quadrilateral is a parallelogram, and explain your reasoning. So first of all, notice that the opposite sides are not congruent. Okay, these sides are right beside each other. They're called consecutive sides. So these would be opposites and these would be opposites. They don't have the same markings, so we're going to have to say no, this is not a parallelogram. Now down here we do have opposite sides congruent, so we would say yes, this is a parallelogram because the opposite sides are congruent. Okay, again, pause the video and give these a shot. Once you've had time to do them, here are your answers. This first one, notice the opposite angles are congruent, therefore we do have a nice parallelogram right there. Another answer you could give is that the same side interior angles are supplementary. They're adding up to 180. So again, that could be another explanation that would be acceptable. Alright, down here, notice you do not have opposite angles congruent. Okay, the ones beside each other are congruent, but the opposite ones are not, so this is not a parallelogram. Okay, pause the video, give these a try. Okay, the first one, opposite sides are congruent, so this is a parallelogram. Second one, opposite angles are not congruent, so no, this is not a parallelogram. Number 3, draw a picture first. Take a look at this picture. Okay, once you label the picture, even though you see 15, 20, 15, 20, that doesn't necessarily mean that the 15s are across from each other and the 20s are across from each other. So you want to draw that picture to get a good idea of what's going on, and then you will realize, since opposite sides are not congruent, this is not a parallelogram. Okay, here's another theorem that we're familiar with. If an angle of a quadrilateral is supplementary to both of the same side interior angles, then the quadrilateral is a parallelogram. Okay, so notice if we have these two adding up to 180 and these two adding up to 180, then we do have a parallelogram. So let's see what happens here. Okay, in letter A, notice if I subtract these three from 360, I'm going to get that missing angle W. And then we have our opposite angles that are congruent. So therefore, we can say, yes, this is a parallelogram. Notice you could also say same side interior angles are supplementary as your explanation. Let's do the same thing over here for part B. Let's find that missing angle by subtracting those three from 360. You're going to end up with a 60-degree angle there. Notice they're all different. So since the opposite angles are not congruent, or you could say the same side interior angles are not supplementary, again, we are not going to have a parallelogram for part B. Okay? Alright, for this one, we only have two angles. Now they're both 90-degree angles, but we're missing something. We're missing angle B and we're missing angle A. Okay, so simply, there's not enough information here to decide. Alright, we don't know if this is a parallelogram or not because we have no information about A or B. We would need a little bit more info to decide there. Okay, here's your last one, again talking about the diagonals. So if you notice that the diagonals of a quadrilateral are bisecting each other, then we can call it a parallelogram. Remember, bisect means to cut in half, so you have these equal parts. Okay, so pause the video, give these two a shot. First one, diagonals are bisecting each other. We have 18, 18, 19, 19. So yes, this is a parallelogram. Second one, however, diagonals are not bisecting each other. We have a 3 and a 4, a 2 and a 3. Okay, so nothing's being cut in half right here. So we have to say no, this is not a parallelogram. Okay, last checkpoint. If you will pause the video, try these on your own, and then I will give you the answers. All right, number 4. Opposite angles are not congruent, so not a parallelogram. Number 5. Opposite angles are congruent. Okay, so yes, we do have a parallelogram in number 5. Number 6, the diagonals are bisecting each other. We have congruent parts here and here, congruent parts there and there. So yes, this is a parallelogram. And number 7, the diagonals are not bisecting each other in this one. We have a 5 and a 4, a 5 and a 4. Now notice, again, I know you see the same number, but remember the 5 would have to be here and here. The 4 would need to be there and there. Okay, so the numbers are in the wrong spot, so this is not a parallelogram. Okay, here's your entry slip for tomorrow. This one, again, a little out of the box, but really think about what are the properties of a parallelogram. Go ahead and list those here. And then what you're trying to do is show that this thing is a parallelogram. You want to show me how you know. Okay, not just saying that it is one, you have to show me. So here's your hint. Use the distance formula to determine the side lengths. I want all 4 sides. So you're going to use that distance formula to find that, and then compare the sides and tell me what you think. Okay, again, document any questions you have for me so that you can ask tomorrow, and I'll see you guys in class. Have a great evening.